4 terabyte M.2 NVMe goodness here. So it's been a long wait. We've got the Samsung 960 Pro here, and I've got a 2 terabyte version and a different system that has just run out of room for me. It's my daily driver, my Windows 10 VM, and I want to do a fresh build on version 2004. And I need the elbow room, the 4 terabytes of space I've been seeking. It is not from Samsung. It's been a multi-year wait for someone to come out with one. And today is the day I'm going to figure out whether this thing will even work on ESXi version 7.0. So we'll see how it goes. Do I need to update the firmware? Do I need to change the sector size? Let's start with this one. This part here is the heatsink for it. Now let's look at the drive itself. So I bought the heatsink optionally. You'll see it came from Moore Park, California. All right. And this was an Amazon purchase. Let's have a look what's inside the FedEx bag here. So, not the fanciest packaging, but that's fine for gumstick form factor. They're pretty tough. And there it is. Sabrent is the brand. So, this is not as familiar brand and a rather big risk for folks used to something like the Samsung 960 or 970 series that are so well regarded on Amazon for many years now. But there's just nothing else like it. There's no other 4 terabyte option, and multiple issues in the last few months have had me thinking about I really need to do a fresh build of Windows 10 and start all over. So we're going to have a look at the unboxing of these 2 complementary products here. Do I really need both? Do I need a heatsink to dissipate heat? I don't know, but considering I think it was $20-something, seemed like a pretty modest investment to make sure this runs cool enough to not throttle or get held back by thermal limits in a constrained area, relatively constrained, like this motherboard right over here. So let's get started with unboxing this guy. So here's the heatsink. We'll start with that. There we go. Comes with a tool, and oh, there you go, copper. So let's see what the best way to pull this out is. Struggling a little bit on camera, probably just from the end. There we go. Nice. Very nice. So we're going to pull off the sticker and plop it on there. Heavy copper. So looking at it with a FLIR thermal camera is something I plan to do on camera shortly here. And I'm going to probably just go ahead and run it full time with this on there. Now, NAND-based flash actually likes a little higher temperature, but when you've got this many chips on there, the density is such that it's probably a good idea to dissipate it or spread it out a little bit. So in some situations, for the old 2 terabyte days, you could run into slowing it down if you cool it off too much. So this is just a simple Phillips head. So it comes with one of those for whatever reason, and it comes with another thermal pad. I don't know if that's a second one. Looks like it comes with multiple thermal pads here. So I'm not quite sure what's up with that or if they're different sizes. If your drive is single-sided, please add the additional thermal tape here. Interesting. And a shell. I'm not sure why we would do that, and that's actually not the way it goes. There we go. Let me have a look at the directions before I go worrying about that at all here. All right, they're telling me PCI Gen 4. So that would really be if you had a lot more heat, right? I want to point that out. This drive is Gen 3. Now, my motherboard is also PCIe Gen 3. Let's have a look here. If your drive is double-sided, skip to step 5, and they're telling me that put the tray, place the SSD in the tray and the thermal tape, make sure the groove, if the screw is placed at the back of the drive. Okay. Well, I'm going to revisit that. Let's finish the unboxing. There's a license of Acronis here. Not going to be particularly relevant in the world of VMware. Well, we could do VMFS format if we can actually do NVMe pass-through. Okay, seems to come with some sort of case. I don't really care for this much stuff that needs to go in landfill. A little too fancy. I don't really mind cardboard, but alright. And there it is. Oh, very nice presentation, I must say. First impression is favorable. I see copper peeking out that edge. That means the heat is going to be spread across the back of this whole sticker here, which is actually copper. Okay? So maybe I'm not going to worry about temperature, but it is dual-sided, and there's the back. And that's going right against the motherboard back over here. Not a lot of room in there, right? So this will be the first time I've got a lot of memory underneath here. 4 on top, 4 on top here, 4 on the bottom here, and a memory controller right over here. So, even if we do heat pipe style things to wick away some of that temperature, and there is room in this motherboard for it, plenty of clearance, it's not going to do anything for the underside. Or will it? Will it draw heat from the whole chip away? Or, even if I'm cloning, I don't know, a 100 gig file or something giant and keep this thing with sustained writes for a long time, will it spread the heat out enough to really not worry about the heat spreader? I don't know. But that's it for my quick unboxing. And close look at the chips on here. Next we'll get into the installation and formatting and all that software fun stuff. What else is on the printed circuit board here? We got some sort of revision numbers there. And on the front, it's saying developed by Sabrent in the USA. Warranty void if removed. So if we were to go and put stickers on here and then we try to pull it off, if that removes the copper from here, that could be a problem. Alright, now we have the 4 NAND on the bottom. And it seems there's no copper to spread out the temperature, the heat on there. So it's interesting. Copper on the top only. Alright, and I have no way to measure the temperature or see how that's doing on the bottom unless I did a standing up PCIe adapter card where I could look at the front and the back. So I'm going to have to think about that, but this is an expensive product. This can be for my daily driver. I'm not particularly interested in torture testing it to push its limits, right? Thermal throttling will prevent it from damaging itself, one would hope, but I have to think about how far I want to push it. This is not a sponsored post. This is my own money that went into this product, which is going to be, again, for my daily driver, even 4K editing, all my daily driver needs in my Windows 10 virtual machine, which actually has a GPU in it as well. So, anything else in the box to show you here? By the way, it's humid. There's no danger of sparks or electrostatic discharge damaging anything here. Is there anything interesting to see in the manual? That's kind of silly. There we go, M.2. Yep, basically just put a screw in to fasten it down and install Windows. Let's see if they talk about sector size or anything like that. They do not. So, if I'm able to format it VMFS as is, this the 4 terabyte version I'm looking at, interesting that you mention it there. If I have no trouble formatting it VMFS, I'm good to go. Let's just finish up with what on earth would I be doing with this? So if we have a look at these two items together, seems rather simple to put them together. But again, this heatsink is meant more for a PCI 4 device. It's actually marketed for that. Do I need it or do I want it for this device? That's where the jury is still out. Let's see also what's the difference of this extra thermal pad. It's the same size. And then this one's put on a little bit diagonal, a little bit scuffed up. First thing to do to get this installed will be to back off the tightness of this screw here and lift it out entirely, actually. And this is a very lightly magnetized tip here on this screwdriver. That's nice and long and goes straight in from the top on this Bundle 2 Super Server. This is the mini tower. Super Micro chassis here. So now that we got that ready to pop out, and we've got the set screw right nearby, and I'm going to go ahead and install this Sabrent 4 terabytes in this Supermicro 5028D-TN4T motherboard here. This is the mini tower, bundle 2 from Wired Zone we're looking at. And let me just wide angle for a second here. There you go. So we're looking at this server here, right? Here's the back. Here's a PCIe card with a blank backplate right now. Here's where the M.2 goes, and back to the zoom. Right there, we're going to set that down the motherboard and do the set screw. We do have a PCIe 16, so we could actually add a second 4 terabytes if we have the budget and inclination to do such a crazy thing. All right, let's get the magnetized tip on that screw, and let's get that set right back down again. Very gently, making sure I don't cross-thread it. Very simple to install M.2 drives in such a system. Now when we give the motherboard power again, we should see some LEDs come on. And let's hook up our management and network adapter here. Okay, so power coming up. Yeah, the only LED would be just under the M.2 there. So let me get power to the motherboard on camera. Let's see if we get anything interesting happening. And I could turn down the lights a little bit just in case there's actually any kind of light on the M.2 device. Okay, it appears that's a solid no light source on the device itself. Oh boy, this part's kind of tense. My very first time looking at the server after booting it. You see I'm on the latest vSphere, version 7 with the latest patches, but let's get right to it. The summary tab of the host in question. This is my 8-core that you saw with the lid off that has the drive installed. And what we're about to look for is storage. Now, it's not going to show us a data store because we haven't formatted it yet, right? Physical adapter. That looks kind of promising. Let's have a look at configure. Oh boy. Okay, so we have an NVMe and another NVMe. That's promising. I actually put the 960 Samsung on a daughter card, and then the new 4 terabytes is in there. So that looks kind of good. Let's go to host storage adapters. Double click there to dive in. There it is. The drive is visible and the capacity is visible. This looks good. Oh, I'm relieved. I don't have to deal with firmware, perhaps. You'll see the sector format right there, 512E. Let's look at a 960 by comparison, a common drive. 512E, a 512E for both of them, so we're good. That means all you got to do here is right-click and say Storage, New Data Store. Here we go. Oh yeah, simple. That's it. Now it looks like I have another drive out there too that has not been formatted. An 850, okay. I'm not going to worry about that one right now. So we need to call this something. Now I'm going to go with my naming scheme, and I have to look that up, so I'm going to rename it after I create this guy. VMware ESXi enables advanced format 512E and automatic space reclamation support. So we're going to want to pick that. Now for size. Do I want to trust this consumer drive and its over provisioning and its housekeeping and garbage collection, all that good stuff? I don't think I know enough about it yet. So I'm going to do my little trick here and back off a little bit on the storage. So what if we take, say, 5% of that? So let's just fire up Excel. And, well, equals A1 times 0.05, and then equals A1 minus A2. Okay, so what if we back off to 3625? So now we've got 95% of the space formatted, and we're just leaving a little bit out there for just in case this consumer drive doesn't handle stuffing it full to 100% someday, which will probably inevitably happen. And I don't really want my performance to tank by really filling it up to 100%, where it has to do some magic to keep things going. It's not like an Optane drive, right? So that's my little cheat there. So we're going to end up with 3.54 terabytes available, GPT VMFS 6, and this should finish up nice and speedy. In fact, it's probably done already. Whoa! I'd say that was fast, wouldn't you? Yeah. It started and finished in 1 second. It took 1 second elapsed. Nice. So this is pretty exciting to see such a big drive that is so performant, presumably, and we're about to find out, right? And let's now have a look at data stores and give this thing a much better name. Okay, and actually we can look at all my data stores from my clusters. And you can see I have a bit of a naming scheme going on here and a drive that it looks like I pulled out, so I have to clean that up at some point. But we've got the Sabrin here, but it's sitting in this system. And let's go ahead and click on rename and get that in the clipboard. Triple click, copy, Control C, cancel. Cancel is key there. And then right click on this guy, triple click to highlight everything, paste, but don't hit enter yet. Still, the drive itself, that's what it's called. So now you can see how it jumps in the list. It sorts nicely. It looks big. It makes it visually obvious which drive I want to clone to as I'm about to do some testing of VMs. Now let's have a look around for what VMs we have over here. I think I'm vMotioned them off. Looks like I might have one candidate. So yeah, I'm going to go ahead and stage. I need a Windows 10 VM to boot without Windows Update happening and all that stuff. So I'm going to have to look around a little. Looks like this might be a phantom drive that I moved. So yeah, we're going to have to look at that a little bit and see what's going on there. And then I've got a SATA SSD. That has a whole bunch of drives. Great. But they're a little bit older builds of Windows 10. So I got to fire one up and see which one I want to actually use. Let me get that going here where we get an identical VM on the Samsung, and then I'm going to clone it over the Sabrent and see how we do for speed. Yeah, I think this drive has actually been booted recently, this VM, excuse me. So let's have a look. If we look here at the list of files and we sort by modified, folders that have files that have been modified pretty recently, meaning it's been booted pretty recently, they show like this. So Win10 Prime. So this one is a good candidate for me to go ahead and open. Now Win10 Prime on Supermicro 1541 is the VM we're looking for. So there's so many of them here, let's just do that. Okay, this is the VM we're talking about here, right? And if we minimize that, we can have a look at storage and you can see it's hanging out in the Micron. So that's the one we want to copy over. So let's clone it. Now there it is, right? The capacity and the name are dead giveaways. And I'm going to keep the suspense going a little longer. Let's put it on the Samsung 960 that is very common. The one that has parenthesis 1 apparently is the one that's valid right now. A little weird, but all right. And let's see how long that takes. So let's crank that open. And let's see how long this overall task takes to run from start to finish. That will become our baseline. This one happens to be, I think, a measly 512 gigabytes. Relatively small. All right, soon. There used to be an elapsed time column on vSphere web client, or the Windows installed version of vSphere administration. So you used to have a column here where you could say how many seconds elapsed. Now it's going to make us do a little bit of math. It's almost done. There we go. All right. It came up 4 seconds. So 56 seconds. Okay, so we got that recorded right here, 56 seconds. Let's move on to the next clone of interest. We're going to take a clone from the same drive, right-click, clone to virtual machine. And I gave it a horrible name. I'm so sorry. That's frustrating. So what do we have to do here to clean this up? Well, we've got a Win10 on Sabrent, right? And that's a horrible name because it's not true. So we got to fix that before we go any further to not confuse the issue. Okay, so that's our first VM that took 54 seconds to do. Next, back arrow on the mouse button and clone the source again. Clone to virtual machine. paste in from the clipboard. Something like that will do. Hit next. And now we got to select. Hit next. And this time make sure to pick the Sabrent. Here we go. And she's off and running here. Now normally I put the start time at the top of the sort order, so that pops to the top, the recent thing we're doing. And we're about to see how long this takes. So this is kind of drum roll moment number one. I got the lid off, I have no fan or heat dissipation going, just the Sabrent there in the air, open air, with limited airflow over it since the lid's off, meaning the fan, the front of the case, the 120 millimeter in the back of the case actually sucking air. It's not really moving air much across this drive. So this is kind of a, challenging test. Okay, this is number of seconds here. Almost done. A few more seconds here. I really don't know how this can perform. I've read the benchmarks. By the raw numbers, it looks good, but sustained throughput abuse like this can be quite revealing in my experience. So I don't want to draw any conclusions before this thing is actually done. But it looks like we're still, ooh, yes, 52 plus 3 seconds. 55. So a tie. So they're about the same, probably not statistically different. So now, you know what it's time for. It's time to boot these suckers up. So let's get a little bit more organized with these VMs here. So we've got the 2 VMs to boot, right? Boot them both up. Since they each have their own PCIe 4.0, PCIe 3.0 by 16, but each one uses only 4 lanes of the 16 lanes. We're good. They get full speed each. Starting with the same moment without a script is difficult because the mouse has got to click, so there's going to be a little bit of a delay, but let's start the Samsung slightly ahead. Pretty much neck and neck. All right, so here they go. This to me is like fun. Not really benchmarking, just informally kicking the tires, but getting a sense, are we in the same ballpark as far as performance of these 2 VMs? Now they're both going to want to hit Windows Update. So okay, the network adapter is disconnected. That's good for both of these. That should remove the prospects of Windows Update getting in the way. And who's going to win? All right, so there was a Windows Update queued up, and that should be keeping the disk I/O pretty busy. So let's slide this up to the top a little, and let's get some real-time stats showing here. But so far, it's looking like the Sabrent's coming out a little bit ahead. So that's already kind of an interesting result. If this thing actually is bigger and dethrones the 2.5, 3-year-old device, then that's pretty good by me. Let's have a look at the host, monitor, performance overview, real time. And we could look at the disks. Let's go back and look at that later after we get that going. All right, there we go. Got the moment of truth. The auto login to the desktop. Boom, it won on the right. And I'm looking at a clock where that was 40 seconds after the hour, after the minute, excuse me, and okay, 8 seconds later. So not really probably not really statistically significant, but there you have it. You're seeing the Sabrent do quite well. So this is good. This is going well. This was really smooth. So if anyone's wondering if this is a good idea to try this 4 terabyte drive or it's going to work under ESXi 7, your answer is a wholehearted yes. Let's show you the version of 7 on here. This particular one has this build, 942. And I'm going to have a quick look at my own article here. Go into the latest. The build that ends in 942 is actually the latest. So we are on 7.0b for this little test and the NVMe that comes with. All right, CPU's kind of busy. What's up with that? Well, that could be because is Prime 95 running in this guy by default? Let's see what this VM is doing. Not much. All right, the default view of Task Manager is not right here, but let's get this going here. Okay, yeah, these things are idle now. So what we could do is a little bit of disk benchmarking, right? So let's do it. Let's oh gosh, this old tool. It's just so handy and easy to run. I think Crystal and others might be installed in this VM too, but let's just start with this really old tool. You can start with the Samsung, and I've established that it doesn't matter if you're in a PCIe add-in card or on the motherboard on this particular system. So I'm not particularly worried about running these both simultaneously, but it is better to run one at a time. So I'm going to go ahead and time-lapse this and let you watch a sped-up version as we run this test. All right, that finished. Now you're looking for a trail off here. If you get thermal limits hit, this number will fall. So let's see how we do over here on the Sabrent side. All right, these numbers are stupendous. Now it looks like I forgot to put this on disk view when I was running that. But anyhow, look at these numbers. They're the same, and then at 4 they start to creep ahead, and pretty much neck and neck, and then things really start to scream ahead at this 256 size, and then just stay way on top. So this is considerably faster, pretty obvious from the graph there. Let's get these a little closer for your eyeballs, and you can see that things are going well for the Sabrent. So my initial impressions are quite good, and that's a relief with this kind of money spent. Now, will I lose all my data on it someday? I don't know. Obviously, I'm going to be doing daily backups. In my case, it'll probably be Veeam agent style or the Kiva or Veeam VM style backups. Regardless, you've got to always back up and expect your drive to eventually fail. This is, again, is a consumer drive, just like a Samsung was a consumer drive. So you can't expect warranty support should this thing fail prematurely. I do see a little bit of trail off here that could be indicative of the temperature rising. So I'm probably going to go ahead and put that heatsink on and just run it again, right? Now, let's just see if Crystal's on here. Looks like maybe no. Not installed anyway? Yeah, it is. Okay, cool. Let's do a quick run of Crystal here on the left. All right, I'd say those results are very favorable. Things are looking good for this drive, but it doesn't have a graph, so I'm kind of a fan of the graph. This is a horrible idea if you're trying to look at a VDI environment for multiple users, because this is a server. But in my case, I'm using it as a workstation. Most of the time, the Windows 10 VM is the only one I care about in this particular system. And actually, I'm probably going to move it over to a 12-core system I have for my daily driver. So let's go with Atto disk benchmark instead. And I'll go ahead and minimize or get rid of that for now. We don't really need that. We already saw the pattern. Now we got the benchmark ready. And yeah, let me rearrange a little more. So I'm just going to do multiple runs. And I might actually do a clone operation before I repeat that effort. So cloning. Why would I clone? Well, let's just see. Oh, VMware Tools update. Interesting that that showed up now. Will it make a difference going from 7.0 to 7.0b? Probably not. But since I've already run some informal benchmarks in this video, I'm going to worry about that later. Interesting that that took that long to show again. That's a little unfortunate, but all right, here we go. Clone to virtual machine. And let's cancel. Let's do my technique of rename. Put that in the clipboard, right click, clone to virtual machine. Give it a copy to name, something like that. All right, and we want it to go right back in the same drive. And compatibility issues, something to worry about. All right, also I'm doing it out of order. So I've been doing Samsung first. So let's actually do Samsung first again for this first clone. So clone the virtual machine, paste, give it a suffix of 2. Next arrow twice should bring me right to the same host, but we do need to find the Samsung 960 Pro 512. Yeah, this is the one, the suffix of 1. Compatibility issues, let's see what that's about. Okay, there's definitely some confusion there. Let's see if it lets me clone it. It is. All right, so it's letting me clone it. We'll get a nice valid test here of how long that takes. And we can fire up old Excel to kind of record this. Okay, we can kick off the next clone. Right click, rename, put it in the clipboard. Right click, clone. Next, next, find the Sabrent. Finish. Whoa, that was fast. Okay, so the first one took, so the Sabrent's doing much better for on-drive cloning. This is awesome because thermal throttling is not going to happen in that few seconds generally, or even if it did, it would only slow maybe down the end of it. But I'm seeing just really good performance here. That's a real world operation. This is not an artificial or synthetic benchmark or even a boot test, which you already witnessed. This is cloning, which you regularly do on VMFS data stores when kicking around in a home lab. And being able to clone that quickly on a 4 terabyte drive is pretty stupendous. So yeah, I'm not sure why the Samsung is a little slower than some of the original benchmarks that I ran when it was new. So not quite sure what's going on there. So this might not be the most fair trial, but either way, I think these numbers are exceeding anything I got even on the, actually I have some articles in the Samsung where I did benchmark it. So I'll look those up. I did mention I'm going to do some more of this stuff. So let's see if we see that trail off, and this time I'm not even going to bother. I'm going to run them both simultaneously. And I think we'll get the same shape curve, and I don't think temperature or motherboard throughput is going to matter at all, because NVMe is really light in this CPU use. Let me show you that. So if we go back here and look at monitor, overview. Okay, we're looking at real time here. And CPU use is nice and low. No big deal there. Okay, so now we've got 2 VMs banging away at this subsystem. Queue depth was not a problem. All right, in a few more seconds, we're going to see some spiking there. So this is a really nasty test, right? And if I were to compare the screenshots, I suspect they'll probably be very similar, even though they're running simultaneous, like I said, both abusing the PCIe bus, but both have their own dedicated 4 lanes. And now we're going to see the drive on the right pull ahead of the Sabrent. Okay, it's time to get this heatsink installed, and again, there's plenty of room for it to go on top of this device. But I'm going to go ahead and take the screw out, take this card out, and make it easier to get to this, and go ahead and put that heatsink on now. Okay, that was simple enough. So, I'm going to grab an alcohol wipe and make sure this surface is clean. And then we're going to peel back this sticker. That's it. So, be right back. We'll want to make sure it's dry, of course, before applying it. Not that I see any fingerprints on there, but all right. And given the matte texture of the surface, I can actually see it drying right before my eyes. That's it. So here we go. All right, now thinking about how it goes in the motherboard there, let me see, those copper loops stick out the same amount on both sides. I'm going to go with more copper sticking out at the far end, but I want to double check the instructions to see if it gives any guidance on that. So here it's showing peel off the thermal protector. If your drive is double-sided, go to step 5. Okay, so they've got the notch in the side that has only one copper loop showing. We actually want it on both sides. So I don't really see how this is going to fit, but we'll give it a try. So that means it's going to go on the back side here. Let's de-energize the motherboard. It's going to go on the back side here and fit something like this. Right? The motherboard has no power. We're plugged in like that, and it's actually going to be like an assembly there. So do you remember what I said about the notch? We're going to line up the notch, and it might be easiest to hold it by the pins. That'll work. Okay, get this lined up and centered. Okay. Press down. You remember I said the side that has one less copper thing sticking out, that's for the screw head, right? That makes sense. So now this goes in place, and I can feel the thermal tape is now doing its thing. You can see it's a nice sandwich here. So both sides are getting the cooling effect. And now we need to get those screws in that it came with. Okay, you'll see I have to exert some pressure here, some squeezing force, to get that hole lined up. No cross-threading going on here, and now it's got a nice countersunk screw head. All right, so now that we've got everything positioned nicely, it's time to tighten all 4 screws to make sure we're good. All right, now we're ready to try this out in a motherboard that has no power, and hope that this thing actually does not get in the way. This is a little daunting, such an expensive thing. Sorry for the camera movement there. Let's give it a shot right on camera. All right, that lined up nicely, and that dropped right in place. Nothing is touching. Are we shorting anything on the motherboard? Well, let's have a look around. The answer appears to be no. This sticks up a little bit, this hunk of metal, but it seems I should be hovering. So it'd be a little bit more reassuring if there was something on the bottom like foam tape, but then it would not dissipate heat as well, right? So we've done this install in the recommended way for a 4 terabyte drive that has NAND on both sides. So now we'll see if we get a little bit of reduction in the amount of potentially thermal throttling that we saw on those Atto disk benchmarks. Get that screw head in there. This is again where a magnetized screw head is going to be your friend, coupled with a little bit of fingernail guidance. And I'm still having a little bit of trouble. So yeah, it's definitely going to be a little, harder to mount the drive once you've put it in a heatsink like this. Don't quite know if the camera is really getting in there with the light. Sorry about that. Now I'm ready to put this Untitled card back right in here. And now we get two drives. They're not touching each other, and I should be able to get the FLIR thermal camera in there as well. Okay, so now we're going to turn the unit on with the FLIR thermal camera aimed. And not much is going to happen until we actually do something with the NVMe drive. But we can see we're at around 91.7 before exercising the drive. Okay, I've got some low battery issues here, but I'm powering on that same VM I was using yesterday now. And the Sabrent is aimed, the FLIR thermal camera is aimed at the Sabrent's logo because of parallax effects and because of being so close. The visual imagery that the FLIR thermal camera overlays on the device is a little bit off, but basically the bright yellow you see to the left of the bullseye there, the bullseye being this right here, this part is very bright because it's hotter. It's the 10 gig interface. The drive is heated up a little. We're at 100 plus, just a little bit. And now I'm starting up Atto. And now it's running. We should see the drive heat right up. All right, interesting results here. Now to compare apples to apples, let me slide this out of the tripod here. What I want to do next is put this drive back in place next to it. I gotta shut down to do that, of course. And that way I'll have another run that looks just like yesterday. So we got up to 106.5. It warmed up a little bit, right? But over here is what I want to show you, and that is this. That is no different than yesterday. We are still losing at the top end, which could indicate thermal throttling, or it could just be the way the drive is always going to perform. So I'm not sure what to make of that, but let me get back to reassembling things the way they were. And there we go, reassembled just like it was yesterday, open air without the lid on. Fan speeds, everything set the way it was yesterday to compare apples to apples to see if my performance differs in any meaningful way with the heatsink on versus yesterday without it. So I'm going to do the same exact tests. Stay tuned. Okay, it's a few days later, and I've given this some thought, and I noticed something about the way I mounted this. So I already know I didn't quite position it right. And the way you know that is, if you look through here, you should see it's completely unobstructed. And what I noticed is, with a little bit of a force, just a little bit, I can actually wiggle that around a little. Let me show you. So the foam moved a little bit. So what that means is if we look straight down here, we now have a little bit of metal in the way, you can see here, right? But if I exert just a little bit of force, we have no metal in the way. In other words, I should be able to get the set screw down without a problem, with just a little bit of force on the foam there. So even though I didn't line it up right, let me just sum that up. When you go to install this, don't do what I did. This can stick way out, right? But it doesn't need to stick that far out. So you're going to want to make sure you have this lined up on that back edge there. And mine comes up a little short, right? So if only I had had that even like this, we'd be absolutely fine. So it's that simple. All right, so let's go for this again. I've de-energized the motherboard, no shorting for us here. I've unplugged the power, and the camera's kind of in the way, so it's a little harder than it should be. So the screw head now looks like it's straight down. Just a little bit of force. I've done it. It is not stripped. It's gone in. And it's done. Success. So I just spotted a very interesting review on Amazon. Right here, someone who owns it for a year. The 512, mind you. But let's have a look at Crystal a little closer. And let's bring up my result here. Oh, there we go. So yes, what does it say? They're showing numbers that look pretty similar to what I'm seeing, right? Let's get that on the screen and slide this over a little bit. So for this kind of performance to happen in a VM, it's pretty astounding. I'm actually doing better in the writes. I'm doing way worse here, but it's not the same value. So we're running a different version of Crystal Disk Mark, unfortunately. Well, that's too bad. But my Yeah, I'm not sure what to make of that. They're completely different values, so it's hard to compare, but the first row at least. Well, a big surprise here, and it wasn't immediately obvious to me. When you see the old versus the new here on the left versus the right, there's a performance boost on the Sabrent with the heatsink. So yes, it's now July 7th, a day later. And even better than just showing this, how about I do a screenshot from yesterday and today? So let's go ahead and compare those. Screenshot today, yesterday, right? Whoa, that's a big difference. Do you see the, whoops, huge climb on the right? Across the board, it is faster, a lot faster. So the heatsink is looking extremely appealing to me. That pretty much wraps up all my testing, right? I wanted to know if I'm ready for my production Windows 10 VM. I am. I wanted to establish whether the heatsink makes a difference. I did, and it's a large one. And I'd want to see how the benchmarks look before and after before I do a real-world test. That's one thing I have not done yet. So let's do a clone, just like we did yesterday. So while this test is wrapping up, I'm going to get that spreadsheet ready, and we'll do a clone, and we'll get an idea of what cloning Windows 10, how long that takes today versus yesterday. So with heatsink, it was 1 second longer, not statistically significantly different for a straight up clone. So that goes back to synthetic benchmarks. How much value are they in your everyday use of the drive device? Well, for hero numbers that you get from a benchmark, the heatsink seems to have made a difference. For normal everyday use, well, probably not so much for 27 seconds. If we did for longer, like a bigger clone image, maybe we get a more substantial difference. It's a few days later, and I just finished updating VMware tools in this guy and the other one on the Sabrent. And the boot time is about neck and neck, a little faster on the Sabrent again. So anyhow, that should get rid of this big nasty warning about VMware tools. But more to the point, I wanted to show you a little bit about firmware updates. So it looks like we need a little more time for tools to show up, but firmware updates, right? How would we do them? Well, we don't know if we need one, first of all. And the first step would be, let's query the firmware we're at. So I don't think there's a new version. I don't think I have a reason to, but I do want to at least cover, how do you know what firmware you're at? When you're in a VMware ESXi environment, you don't have access to like a Windows tool for your consumer drive, like a Sabrin or Samsung or Toshiba or Intel or Micron or whatever. You kind of got to, well, you'd have to dismount and do some pass-through stuff with RDMM. That's a little crazy. Or even pull out the drive and put it on a Windows machine. That's ridiculous. Let's just start with, how do we get the firmware out of there? So, just so happens I have an article about that. I wrote it 3 years ago, but it's still just as true today as it was back then. And it's pretty straightforward. Basically, we're going to copy and paste this into a PuTTY session, SSH session, excuse me, whatever you are on, a Mac or PC. Just open up your SSH session to the ESXi host in question, where the SSD is installed. And you're going to then copy and paste this whole line. So Control C. And let's go ahead and minimize that. So this is just showing the host that this Sabrent is installed on, right? So that's how I knew what host to SSH my way into. And there's going to be a lot of stuff coming out of here. Not on this first command so much. There you go. That just egreps. It looks for 3 things, and it gives us the firmware version. But there's actually a whole lot more info you can get if you want everything, all the available info on your new SSD, whatever brand you're using, including things like serial number. Say you were opening say you had a problem or you needed support or something. Maybe they asked for serial number. I don't know. So there you go. I just want to include that little footnote. And I'll also mention that I did manage to get the update VMware tools to go away. It was orange, but not by refreshing here after updating VMware tools. You had to actually click like away on it and go back to it, and then the orange warning about VMware tools went away. So I did a boot order change. Well, basically I didn't really change boot order. I just popped out the SSD that was in there and put in a 970 that already had Windows 10 on it. So that allowed me to quickly reboot. And here's the keyboard, video, mouse, way of seeing that. And then I went ahead and remote desktoped into the machine. So what I'm trying to do here is get to this. Okay, we got the firmware update utility from Sabrent. Now, before I actually run that, I want to see if we can have a glimpse at what our firmware is currently from within Windows. If we look deep into storage devices, nope, we're not going to find it there. How about disk drives? Maybe. Go to properties, go to details, and change to hardware IDs. And this can give you a hint at the firmware. Let's see if 43.1 ends up meaning something. We'll find out soon enough. All right, time to go back and try the utility. And this is my very first time trying this utility. We'll go ahead and save it into our downloads folder and see how this goes. Not a big fan of that. There you go. All right, here we go. What's it called? Well, let's extract it. And open it up. All right, finally we're ready to run the application. Is it portable or does it make me install it? Oh. So I've got the wrong tool here. So the 4 terabyte Pro apparently is not really what I have. Failure. This is a draft, so you're not going to see that article exactly like that when it goes live, but anyhow, I'm giving you a peek anyway. Here's the main firmware updates page, so let's have a look at that. Do we see a utility here that looks like the right one? Well, if we search for 4 terabyte, there's only 2 hits. Okay. So that jumped over to the same page. The same page. So that's pretty sloppy and weird. Okay, so apparently, click on download. Might get me somewhere. Let's see if that's the same exact thing I just downloaded. And it is. Parenthesis 1 is what that means. So it looks like there is no more recent version. Let's see what View does. View brings up the product page I started with this video. All right, let's navigate their website together a little bit. So sabrent.com/downloads brings us to here, and we need to type a model in the search box. So let's head back to my article. Shopping. There you go. So what is the manufacturer product number or name? Date first available. All right, there it is. SB-Rocket-4TB. So that's my product name. We're going to close that utility because it did no good. Because it's the wrong utility. And now let's head over to here, put this in, and this is what comes up. Great. So we'll download it and save it. Make sure it goes into my downloads folder. And normally I have Chrome. This particular system only has Edge. That's okay. Okay, we got to expand it. It's a zip file. And now we're ready. So it's time to run the utility that should allow me to check if there's a later firmware available or needed for this drive. Looks like another extract is needed. That's a little bit of work there. Okay, nice. I found the drive. Probably not the German manual. Sector size convert. Okay, so if we wanted to change from 512 or 4096. We have a utility to do that. Got it. How about just a firmware update? Let's give it a try. How about under software? Well, in my clipboard is still the model number, so let's have a look around support just a little bit together here. And no. How about under products? Let's see if we can find the product page and see if that links. See if that links to a download. Here it is. Okay, so now we're on the product page. And we're looking to see if there is any further information, maybe a link to downloads. How about additional information? There's our model number and dimensions and all that. Let's do one more search. Anyone talking about it? Not really. So none of those links are really about firmware. Wow, nice pictures though. All right. There's a downloads link. And we are back here. Size converter we just ran. Upgrading firmware. Okay, here we go. Product line here. And we're done with the converter because we're not doing a conversion. And now let's try Sabrent Rocket Control Panel. Nice. Okay, we even get thermals here. I'm liking that. Yeah, before I go updating the firmware, it'd be kind of cool if I could do a little bit of drive abuse here. And it looks like I don't have any such utilities handy. Okay, I've got one in my clipboard. Let me just paste it over there. Portable old tool that runs just fine, and we'll abuse the heck out of that drive. All right, what do we have here? Drop down list here. Okay, obviously we don't want to point to a third-party drive, but just try it anyway. Let's see what happens. It shows the sector size and firmware. Pretty cool. Let's go back here. The exact firmware in a somewhat hard to read font there. And our temperature, I don't know how often it updates that, but our drive health is showing happy. That's good. Before we get to firmware upgrade, let's click on all the other items. Tools. Okay. Talks about the utility. Cronus for backup, and the size converter with a link to it. Okay, that just launched rescan. Just relaunched the whole user interface there. All right. And the temperature supposedly staying exactly the same. Smart details. Shows the temperature. Spare threshold, interesting. How much data has been written? Only 335 power hours, 6 power cycles. Pretty cool. Terabytes written, very low. It'd be great if I could check that from within VMware. I'd like to look into that at some point. As I have in the past, contact us, simply gives you information. And then finally, firmware upgrade. Finding it pretty interesting, at least with the heatsink on, temperature's not changing. Again, having a really hard time believing that. And that would be because I'm on the wrong drive. We're not going to see it as a drive D. It's got a VMFS file system on there. It's formatted and ready to roll with VMware's file system. So I would have to nuke everything I did over in VMware and reformat it VMFS. So let's go to disk management. That's a better view. And there it is. You can't see what's on there, right? Let's delete that. Away it goes. Pretty nasty what I just did there. Be very careful if you were to attempt something similar. And we're ready. That didn't take long. Okay, no drive D, so we got to relaunch the utility. That's expected. Okay, now it's going to find a drive D. And we can abuse drive D and we'll see what the temperature does. Okay, that went well. Temperature is not a concern at all. 111 max, big deal, 44 Celsius. All right. There you go, I'll screenshot that and put it in the article. All right, let's move on. Firmware, here we go. If you decide your data will not be affected, interesting. Even talks about the memory module, cool. And there's no information. Okay. No information about my device at the moment. What does that mean? Switch over to the wrong device, switch back, hit firmware. Again, check now. Fail. Let's try it again. Launch the user interface all over again. I suppose we could do this. Right click. Again, not the easiest to read blue font there. And what just happened? Did Windows just throw an error? Probably not. Maybe a system error, application error, excuse me. We'll have a look on it over there next. But yeah, it seems like the app just didn't show up. 1044, okay, how about a 1044? Okay. So, doesn't like me running it as admin? Let's see if the problem happens every time. That was weird. Okay. We're good to go now. Moving along. It shows the Sabrent by default. So I should be able to just click firmware update. Check now. And nothing. That's a huge difference. So the writes, obviously the Sabrent is trouncing. It's a much newer drive as well. Thank you so much for watching this video and for visiting Tinker Try IT at Home, where you'll find a whole series of vSphere 7 articles. And then if you click on videos, you'll see a vSphere 7 playlist. If you do take the time to watch a video, please consider a thumbs up and subscribing. It makes a huge difference. So few people actually subscribe that watch them or even bother to click on thumbs up. And it really makes a difference for other people to get to see those over on YouTube. Thanks again. Bye now.